So here we go. Solving system of equations using the addition method. Now, if you remember, what your goal is to make the coefficients of either x or y the same, and then when you add, which is what the addition method is, one of the variables drops out. Now, the way we're going to be operating with this thing is we always work from left to right. Here, if I were in an algebra class and I were doing this by hand myself, I noticed that here the coefficient of y is 1, and they are already of opposite sign. I would multiply the first equation by 3 and add, and y would drop out. But when we actually work with this stuff, with what we're going to be doing, we're going to be killing the variables from left to right, which means we start with x first. Now I'm going to start with some notation that I'm going to use all the way through that's going to carry us into the topic of matrices. And I'm going to label the two equations. This is equation 1, this is equation 2. And I'm going to tell you what I'm going to do. I'm going to eliminate x, because I'm going to work from left to right. And then how am I going to eliminate x? I'm going to take negative 2 and multiply it times the first equation, and then add it to the second equation. Now, if I've done it correctly, the x's will drop out, and then I will solve for y. So it says negative 2 multiplied times the first equation's going to give me negative 2x minus 2y equals minus 2 times 8 is minus 16. And I'm going to add it to the second equation, which is going to be positive 2x minus 3y equals minus 9. The x's add to 0, so essentially what I have here is a 0 times x. And I get negative 5y equals negative 25. Solve for y, divide both sides by negative 5. I get that y equals negative 5. So now what I'm going to do is, I know that y equals negative 5. I'm going to find x.
5 equals negative 5 or 5?
5, yeah.
Oh, it should be negative 5 over 20, so this should be positive 5. Thank you. That would have made a difference. So I'm going to use equation 1. So I'm going to use equation 1, so I know that x plus y equals 8, or x plus 5 equals 8, or x equals 3. So x equals 3, y equals 5. We can look at this as being as the coordinate point 3, 5. Now, if you remember what this stuff is, and you may not, I have two equations. And that would be kind of like what they would look like. The point of intersection of those two equations would be 3, 5. It is the shared common coordinate point between these two lines, and these two guys are lines. Would be 3, 5. So you're looking at the intersection of the two graphs. And that's what a solution is. It's the intersection of the two graphs. And that's what this 6.2, and actually this is what chapter 6 ends up being all about in the end. We only do 2 sections. We do 6 in the spring. We do 6.2 and we do 6.6. In the fall, we have more days. You know, there's more class days in the fall than there is in the spring. And so in the fall, I actually have time to do another section or 2 out of 6. But you're not going to be hurt if I don't. So now we're going to get into the idea of what a matrix is. So that's what this section is all about. It's about matrices. And a matrix is an array of numbers, and this is what it looks like. Sometimes, by the way, you'll see big parentheses depending upon what book you're in. Our book tends to use square brackets matrices. You'll see when we start moving it to the calculator, your calculator actually use square brackets for matrices as well when we go to set it up. And it's an array of numbers. So that says what I have is essentially something that's got rows and columns. And this particular matrix has 2 rows. So this would be row 1, and that would be row 2. So it has 2 rows, and it has 1, 2, 3 columns. So column 1, column 2, column 3. And that's an important thing to know as we begin to transfer all of this stuff to the calculator. So he has 2 rows and 3 columns. We say the size or order, depending upon the book again, sometimes they'll call it the order of the matrix, sometimes they'll call it the size of the matrix. We would say is a 2 by 3. Often written in a way it's usually written is like 2 by 3. So it's not 2 times 3, it's 2 by, that means by. If you were going to be going to a lumber yard to buy a 2 by 4, that would be the notation you would see. So 2 by 3. In this particular instance, I have a matrix, and I notice that he has 1 row, and he has 1, 2, 3 columns. So you're looking at the size or the order is a 1 by 3. 1 by 3. So the notation is an m by n. So it's the number of rows by the number of columns. So an m by n would have m rows and n columns. Matrix.